This lesson comes from section 3.6 in your textbook. So you should have seen the quadratic formula sometime before in your previous math classes. So we use this when we're solving, again, a quadratic expression set equal to 0. So that's in the form ax squared plus bx plus c. And, of course, b in the formula represents the number in front of x, a is the number in front of x squared, and c is the constant term at the end. And then the part of this formula that we call the discriminant is the part of the formula that is inside the square root. We call it the discriminant because we can use it to decide what kind of answers or solutions we're going to get before we actually solve the whole problem. So if we look at these rules for the discriminant, if b squared minus 4ac, or the number under the square root, is less than 0, that means we're going to have the square root of a negative number, which gives us two complex solutions. If you remember from section 3.3, complex just means that it's part real, part imaginary. So there will be a real part plus or minus an imaginary part. And usually we get that from the square root. Okay, and the reason there's two complex or two imaginary is because if we were to graph this, we would see that the quadratic parabola doesn't actually touch the x-axis anywhere. And remember, when we were graphing these, our solutions were where they hit the x-axis. So when b squared minus 4ac equals 0, that means the number in the square root is 0, square root of 0 is 0, so really we'll just have like our negative b over our 2a, which is just going to reduce to one real rational solution. Or if we were to graph it, the parabola just bounces off the graph, so it just hits it once, or off the x-axis. Okay, now remember, rational means that we can write the answer as a ratio or as a fraction. And it's real because it actually does hit the x-axis. Now, if the number under the square root is a positive number or bigger than 0, we're going to have two real solutions, meaning that it's going to go through the x-axis in two places. Now, depending on what kind of positive number we get, we could get two real rational solutions or two real irrational solutions. Okay, if it's a perfect square, like 25, 16, 9, 4, 1, 36, etc., then that square root is going to reduce to a nice integer, or just a solid number, without decimals, without a square root that we can't reduce. So that's why it'll become rational, because we can combine it with the negative b, and over 2a, that's a fraction. If it's not a perfect square, such as 3 or 5, that's irrational, because square roots that can't be reduced are not considered numbers that we can write as true ratios or fractions. Okay, so let's do an example or two. So here we've got, this is similar to what you'll see in the book. For each of these, we want to find the value of the determinant, use that to describe the number and type of solutions, and then find those exact solutions. So, first thing we're going to do is use the formula inside the square root, so b squared minus 4ac. So for this first example, our a value is going to be 2, b is going to be negative 7, and c is going to be 5. So let's plug that into our discriminant. So b squared, that'll be negative 7 squared, minus 4 times 2 times 5, and that is going to give us, let's see, 49 minus 40, so that is 9. Okay, if we use our rules, we can see that this is a positive number, and it is a perfect square. So this tells us that we are going to have two real rational solutions. And remember, the abbreviation for real is the double-barred R. Two real rational. Okay, so let's see, that's part of our answer. The value of the discriminant was part of our answer. Now we want to actually figure out the whole solution. So we're going to plug it into our whole formula. So quadratic formula is negative b, which, since it's already negative, that will become positive, plus or minus the square root of b squared minus 4ac, which we found was 9, all over 2a, and a was 3. Oop, not 3, 2. It was 2. Okay, so let's reduce that. So we'll get 7 plus or minus 3 all over 4. Okay, so we should get 2 fractional answers from this. And remember, even if it's a whole number, that we count that as rational because we can write, say it's like 6 or something, we can write 6 is 6 over 1. So that still is rational. So 7 plus 3 is 10. 10 over 4 reduces to 5/2. Okay, 7 minus 3 is 4. 4 over 4 is 1. So our answers for this is 5/2 and 1. Okay, let's do another one. So 3x squared plus x plus 7, in this case, a is going to be 3, b is going to be 1, and c is going to be 7. Now if you come across problems where it's not in this ax squared plus bx plus c form, like maybe they have the 7 subtracted to the other side, you want to move everything to one side so it's set equal to 0. Otherwise your a, b, and c values are not going to have the correct signs, and that will mess you up. So make sure to do that. Okay, so let's find our discriminant first. So that's b squared minus 4ac. So that'll be 1 squared minus 4 times 3 times 7, which that is, 1 minus 84, so that's negative 83. Okay, that's our value of the discriminant. Okay, that is a negative number. Okay, so that tells us that that is going to be 2 complex solutions. Okay, because it's negative, we're going to have imaginary results. So we're going to get 2 complex answers, and then let's go ahead and plug it into the rest of the formula. So negative b plus or minus the square root of b squared minus 4ac, which was right there, which we got was negative 83, all over 2a, which this time a is 3. So that's negative 1 plus or minus. Now this is where you kind of have to try to simplify the square root of 83, which, 2 doesn't go into that, 3 doesn't go into that, 4 doesn't go into that, 5 doesn't, 6 does not, 7 does not, 8 does not. That doesn't look like that's reducible really, so the only thing we can do is turn the negative into an I, and we'll have square root of 83 left inside, all over 6. And those are our 2 complex solutions. So really we've got negative 1 plus I squared of 83 over 6 and negative 1 minus I squared of 83 over 6.